many 4-digit numbers are there such that they end in 83, that is tens digit is 8 and units digit is 3 and are divisible by 11. So we have to find the 4-digit numbers. We have to find the 4-digit numbers such that last 2 digits are 8 and 3, right? These digits are fixed. So and these 4-digit numbers that are ending in 83 must be divisible by 11, right? So precisely it's a question of divisibility rule of 11. We know the divisibility rule of 11, right? Divisibility rule of 11 is the difference of alternating sum starting with units digit, that is this digit plus this digit, and the alternating sum starting from tens digit, means the sum of second digit and this fourth digit, right? Or whatever you call it, first, second, third and fourth digit. So the difference between these two alternating sums must be divisible by 11. That's the divisibility rule of 11, right? So I'm assuming this number to be x and this number to be y. Now we call this sum u, right, and denoting this alternating sum starting from the units digit as u. So it would be 3 plus x, right? I'm calling second alternating sum starting from tens digit as t, and it is 8 plus y. So the divisibility rule of 11 says the difference between these two sums, that is u minus t, this must be a multiple of 11, or this difference must be divisible by 11, right? So if I take this difference, the expression become 3 plus x minus 8 plus y, and it should be a multiple of 11, right? So it becomes x minus y minus 5 is equal to the value of this term has to be a multiple of 11, right? First of all, I know x and y are single digits. X and y are single digits. So the range of this term, that is x minus y, would be from the lowest value. This expression x minus y can take is minus 9, right? It can take the value minus 9 because when x is 0 and y is 9, y maximum can be 9 and x minimum can be 0. So I get the minimum value of this term as minus 9, and the maximum of this term would be when x is 9, y is 0, so it would be plus 9, right? So this is the range of x minus y. When I subtract 5 from this difference x minus y, I get the range of this whole expression, x minus y minus 5 will be minus 9 minus 5 to up till 9 minus 5. This would be the range of this expression, right? So it becomes minus 14 and the upper limit is 4. Now this expression has to be a multiple of 11 in this range from minus 14 to 14. So there are two values which are divisible by 14. So it can be from here. I can say that this expression can be minus 11 because minus 11 is a multiple of 11, or it can be 0, right? So if this expression is minus 11 or 0, I get two values of, from this statement I get two values of this difference. X minus y can be minus 11 or x minus y can be 0, right? We have to solve these two equations, or we have to find integral solutions for these two equations where x and y can only take values from this x can be from 0 to 9 and this y can be from 1 to 9. Y cannot take value 0 because in that case this number would not be a 4-digit number, right? So when x minus 5 x minus 5 minus 5 has to be minus 11 or 0. So x at minus 5 would be equal to minus 11 plus 5, right? 5 goes to other side and so it becomes 5. So I need to find the solutions of x minus y which ends in 5 also, or x minus y can be minus 6, right? So taking values of x as x maximum can go up to 9. 9 minus something is 4, so I can place y as 4, right? X can take value 8, it can become 3, 7 and 2. Difference of these numbers is 5, and x can take value 6 and y can take 1. Y cannot take value 0, so we cannot go further. So there are 4 cases possible, right? 4 numbers are possible. Also, these are 4 cases, so there are 4 numbers for these 4 cases, right? Also, x minus y can be minus 6, so y can take value, if it has to be minus 6, y maximum can be 9, right? So x can take the value 3. If y is 8, x can take the value 2. If it is 7, x is 1. If y is 6, x can take the value 0, because I can place 0 at second digit, right? At second digit I can place 0 because it's a 4-digit number, right? First digit cannot be 0. So there are 4 more cases, 4 cases more, right? So how many numbers are such numbers are possible? I am getting 8 cases of x comma y pairs, right? I am getting 8 cases of x comma y satisfying this condition that this 4-digit number must be divisible by 11. So correct answer to this question would be, how many numbers would be there? 8 numbers. So correct answer is 8.